In this section, we are going to talk about geometric sequences. So we saw what arithmetic sequences look like. Now we're going to look at geometric sequences. So this is basically what a geometric sequence is. So let me give you the definition of a geometric sequence. And basically all it is just a ratio, between consecutive terms is the same. So the ratio between consecutive terms is exactly the same. So one example that you can probably think of is 4, 12, 36, 108, and you can continue on, and you can see that here the common difference there's no common difference. In this case, what you're going to get is a common ratio. So the common ratio, the way that you can figure it out is going to be R. So this R is going to be called the common ratio. So just like how we had a common difference in the arithmetic sequence, in the geometric sequence, we're going to have a common ratio. A way that you can figure out what the ratio is, just take the second term and divide it by the first term. So in this case, I take 12 divided by 4. That's going to give me 3. So this tells me that each term is being multiplied by 3 each time. 4 times 3 gives me 12. 12 times 3 gives me 36. 36 times 3 gives me 108. So what do you think the common ratio is of this sequence? So find common ratio of geometric sequence. So what do you think it's going to be for this one? 8, 4, 2, 1, 1/2, 1/4. So what would that be? Well, the common ratio is going to be R is equal to A2 divided by A1. A2 in this case is going to be equal to 4 divided by 8. So 4 over 8 in this case is 1 over 2. So what this means is that each time I'm multiplying each term by 1/2, or I'm dividing it by 2. So that's what that's going to be equal to. So just like how we did before with arithmetic sequences, there is a formula for geometric sequences. So the general formula for geometric is going to be the following. AN is equal to A1 R to the power of n minus 1. And you can kind of derive it just the same way that we were deriving it with arithmetic. You first start off with the first term. In order for me to get the second term, I'm going to take A1 and multiply it by R, the common ratio. How do I get A3? A3 is going to be take A2, multiply it by the common ratio. But since I know what A2 is, which was A1 times R, it's going to be A1 times R, and then you have an extra R. It's going to give me A1 R squared. Then you can do the thing with A4. A4 is going to be equal to A3 times R. A3 in this case was equal to A1 R squared. And then I have an extra R, which gives me A1 A to the third. So you can kind of see that you have A1R, A1R squared, A1R cubed. So when I get to AN, it's going to be A1R to the n minus 1, because what you see is that this number 4 and this number 3 is always 1 less. Here is n and here's n minus 1. Okay, so this is going to be the formula for geometric sequences. Okay, so let's do some examples. So here, find the 12th term of the sequence. So here I'm going to have 3, 6, 12, 24, and you want to find the 12th term. Okay, so the first thing that you want to do is let's first use the formula. AN equals A1 R to the n minus 1. So A1 in this case is going to be equal to 3 because that's the first term. The common ratio, R, is going to be the second term divided by the first term. So that's going to be 6 divided by 3. It's going to give me 2. So everything is being multiplied by 2 each time. And in this case, it's going to be the 12th term because I'm looking for 12. All right. And what I would suggest is use a calculator for this because these numbers can get really, really large. So I'm going to have A12 is equal to A1, which is 3, times 2 to the power of 12 minus 1. Here, make sure that you do order of operations. We always do the exponent first and then multiply by the 3. So first we're going to take this 2, raise it to the power of 11, and then I'm going to multiply it by 3. So don't forget about your order of operations. So 2 to the 11th is going to be a really big number, so that's why I would recommend to just use your calculator here. So I'm going to raise it to the power of 11, and what I'm going to get when I multiply everything out will be 6,144. That is going to be my answer. All right. Now let's do another problem. Find the 11th term of the sequence 7, 14, 28, 56, and so on and so forth. So we know that the formula is going to be an equals a1 r to the n minus 1, and we can literally see that because the common ratio is going to be a2 over a1, which is 14 over 7. In this case it's 2, so everything is being multiplied by 2 again. So now we're going to plug everything in. A1 is going to be 7, and then n in this case is going to be, we're looking for the 11th term, so it's going to be 11. So we're going to have A11 equals 7 to the power, and 2 to the power of 11 minus 1. So this is going to give me 7, 2 to the 10th power. So again, I'm going to use my calculator. 7 times 2 to the power of 10. That's going to give me 7,168. That's going to be my answer for the 11th term. Now you could have easily just multiplied 2 each time and then you would have gotten a number, but sometimes it can be a little bit hectic, especially if n is a little bit larger. Okay, let's just do one more problem. Find the 7th term of the geometric sequence. And my question is going to be 8, 4, what would this be? 2, 1, so on and so forth. So what is going to be the 7th term? So again, this is geometric. So you're going to have an is equal to a1 r to the n minus 1. A1 in this case is going to be equal to 8. R is going to be the common ratio. In this case, it's going to be A2 over A1, which is going to be 4 over 8. In this case, we know this is going to be 1/2. And in this case, it's going to be 7. So A7 is going to be equal to A1, which is 8, times R, which is going to be 1/2, to the power of n, which is 7 minus 1. And all I got to do is just put this in my calculator. So it's going to be 8 times 1 over 2 to the power of 7 minus 1, which is 6. My answer is going to be 1/8. Okay, so that's a little bit of geometric sequences.